The liquid petroleum pipeline industry is focused on operating pipelines safely and reliably. And at the heart of a safe, reliable pipeline system is the control room. There are three primary elements that control rooms rely on to maintain safe operations. First, the control room is staffed by highly trained controllers who put safety at the forefront of every decision they make. Second, in addition to their training and experience, controllers rely on technology to help them do their jobs. And third, controllers follow processes and procedures designed to ensure that decisions are consistent, correct, and based on all available facts. Of the three, well-trained controllers are the most important element in a pipeline control room. Pipeline controllers are dedicated, disciplined, and have been selected for their ability to process information rapidly and accurately. They are trained to analyze information and react appropriately to abnormal conditions. Pipeline controllers understand that their most important role is to help protect the public and the environment. Training to operate in a control room involves several months of instruction and study, covering areas such as hydraulics, pump mechanics, pipeline-specific terminology, how systems and components react to events, and processes and procedures for both normal and abnormal situations. Training also includes practical, hands-on work with experienced controllers who reinforce classroom training by showing how it applies in real-world situations. Once a controller understands basic pipeline operations, their training becomes more specific. Ongoing training uses tools such as procedure reviews, simulator practice, and drills on possible scenarios. When there are unplanned events, investigations are conducted, and then incident reviews and lessons learned are shared with controllers to supplement their training. Controllers are also trained to react quickly when they receive calls from landowners, emergency responders, or other members of the public who report that they have seen, smelled, or even heard something unusual near a pipeline. A modern control room continually streams real-time information to the controllers, covering every aspect of a pipeline's operations. This is the technology component that is so critical to a control room's ability to maintain safe operations. From here, tanks, valves, pumps, even the pipes themselves can all be monitored and operated thanks to high-speed communication equipment and powerful computers. This system is called a Supervisory Control and Data Acquisition System, or SCADA system for short. The SCADA system allows controllers to monitor the pressures, temperatures, flow rates, and specific attributes of all the liquids in the pipelines. The SCADA system provides this information in real time and gives controllers the ability to transmit commands to remote equipment such as pumps or valves. Any conditions that are outside normal operating settings are programmed to trigger automatic alarms, and the controllers are then able to determine if the condition is expected, if it's something to investigate further, or if emergency action is required. At any time, the controller has the authority and responsibility to shut down the pipeline if a leak is suspected. In addition to the SCADA system, many control rooms also use fast, highly sensitive computational pipeline monitoring, or CPM systems, to help detect leaks. As liquids are pumped into and out of pipelines, CPM systems continuously analyze the volume and physical properties of liquids, like temperature and viscosity. This data is used to compare actual conditions with expected conditions, giving controllers another tool for monitoring the integrity of a pipeline. Pipeline operators strive for 100% SCADA and communication system reliability. That's why many operators maintain off-site backup facilities, so that even if the primary control room has to be shut down or evacuated, operations can continue safely. Although technology and people are the critical factors at work in a pipeline control room, what brings them together and makes them work seamlessly are the processes and procedures that govern their operations. From the moment a controller walks into a control room to start a shift, procedures must be followed. For example, a shift change includes a detailed checklist of information that must be passed from the controller who is finishing a shift to the one who is taking over. By the time the controllers begin their shift, they have been briefed on items including alarm statuses, event schedules, maintenance activities, batch changes, and system startups or shutdowns. This procedural handoff is essential to maintaining the continuity of safe pipeline operations. Procedures are also very specific when it comes to dealing with abnormal conditions or alarms. First and foremost, to safeguard the public and the environment, controllers know that they have the authority to shut down a pipeline without a supervisor's authorization. The rule of thumb for liquid petroleum pipelines is to shut down when the cause of an abnormal condition cannot be quickly identified. After the decision has been made to shut down, control room procedures dictate what must happen before the pipeline can be started again. In order to ensure disciplined decision-making, subject matter experts are consulted. These discussions also include personnel who can be deployed quickly to pipeline field locations if necessary. Everyone involved in the decision-making process is trained to rely only on facts rather than assumptions to make decisions. Only after stakeholders and subject matter experts agree that the situation is safe and that all procedures have been followed can the pipeline be restarted. This dedication to following procedures also extends to handling emergencies in the control room itself. For example, there are detailed steps to be followed if there is a loss of SCADA control, or if the control room has to be evacuated for any reason. When it comes to handling stressful situations, especially emergencies, the key to success is preparation. That's why pipeline control rooms practice their procedures with drills on a regular basis. These drills can also involve field operations in order to simulate the complications and uncertainty that can result from a leak or other abnormal event. In addition to pipeline controllers' own dedication to safety, the Federal Pipeline and Hazardous Materials Safety Administration, referred to as PHMSA, has also issued regulations for control room management. These regulations provide a robust framework for how control rooms must operate. PHMSA identified many of the best practices in control room management and mandated them in these regulations. PHMSA also sets industry-wide standards for how these regulations are to be followed and how pipeline controllers are held accountable. Control room management regulations require that pipeline operators define the roles and responsibilities of staff in their control rooms. They also ensure that information flows to the right people at the right time, and that fatigue management is part of a control room's procedures to help maximize controller alertness. In addition, the regulations mandate alarm management and change management procedures, various types of controller training, and detailed documentation of control room activities that affect operations. In today's pipeline control rooms, it's not unusual that every operational event is recorded and archived. One of PHMSA's many important control room management regulations formalizes the process of incorporating lessons learned from incidents and events. This helps ensure that pipeline controllers are focused on continuous improvement, a practice that has been an important part of the pipeline industry from its earliest days. Hearing about a control room's people, technology, and procedures can help you understand how they work in theory, but it's always helpful to see examples of how they work in practice. Now, here's a short video that a pipeline operator has used as a training tool for its new control room trainees. It describes a real incident. Fortunately, in this case, a leak was identified and the pipeline was shut down by the control room in less than 2 minutes. Operations do not always go as planned. This video lets you see what it looks like from a controller's perspective.
Sunday, August the 10th, 2008. The Patoka Owensboro crude system is operating at a rate of approximately 7,700 barrels per hour. At 3:42 pipe time, a switch is made to originate from cap line. The system responds and normal operation continues. At 4 o'clock, shift change takes place between analysts on console number 5. The system continues normal operation as the incoming analyst completes routine check-in tasks. For the next hour and 44 minutes, the Patoka to Owensboro system quietly operates, requiring no intervention. Patoka Capline Booster A, Patoka Mainline Units 1 and 2, Johnsonville Mainline Unit 1, and Albion Mainline Unit 2 are all in operation. At 5:44, Albion Station shuts down on low suction pressure. Seconds later, multiple analog deviation alarms are received for Albion and Johnsonville stations, including suction pressure, discharge pressure, and control valve percentage open. At 5:45, a CPM leak alarm was received for the Patoka to Owensboro system. Seconds later, the discharge pressure at Patoka Station and the Owensboro flow rate deviate low. What would you do at this point in time? What would you be thinking? What would you be analyzing?
I came in for shift change and started the morning. It was a very quiet morning, not much happening. Then Albion Station shut down on low suction pressure, so I knew I needed to stabilize the line. So my first thoughts were to look at Johnsonville, a station that is upstream of Albion, so it didn't go down on high discharge. And I noticed that the discharge pressure was much lower than it was when I came in at shift change, and decided that I better get the specialist involved. As the specialist came over, we were trending the pressures at Johnsonville and Albion, and we also had received a CPM leak alarm at this time, so we were pretty sure that it was a leak and decided we needed to shut the pipeline down.
Patoka's pressure that's coming down as well.
Yeah.
That flow rate's starting to go up.
As a specialist, you start thinking about the steps in the process. Where do we go from here? Because we had to make a decision fast on what to do. We had our pressure descending rapidly at Johnsonville. It came to a decision where we needed to, pretty confident we needed to line down and shut it down fast. From this point, once we decided to leave the pipeline head gate open and drain more pressure off the line, we essentially had the line down, and I had to decide for myself where to proceed from this point. So my first call was to my supervisor to get him involved in it and give him the lowdown on the situation. Then we went to the CPM supervisor to have him take another look at the CPM system and what it was telling him, to make sure that he can confirm to us what we were also seeing. And then from that point, scheduled a conference call with our area superintendent. The conference call involved other subject matter experts, operations supervisors, and to decide on a course of action. From that point was to get a pilot up into the air to fly the pipeline, see if he could confirm a release anywhere along the pipeline. And he did indeed find, from what he described, about a 300-foot spray of crude oil over vegetation just upstream of Albion Station. The station went down a low suction.
Although control room personnel and procedures functioned well during this incident, the fact remains that a leak did take place. In its investigation of the leak, the pipeline operator found that it resulted from a type of failure that had not been previously seen, and therefore was not regarded as a threat to pipeline integrity. As a result, this company implemented several measures to minimize the risk of this type of failure happening again, and shared what it learned with its industry colleagues in the U.S. and Canada. Just as pipelines are an essential part of our national energy system, effective and professional control rooms are an essential element for ensuring pipeline safety. Keeping the public safe while transporting the energy we all need every day is the work of the people who staff a control room. Pipeline employees understand that they are in a position of public trust and strive to operate safely and reliably each day. They take their jobs very seriously because pipeline companies, regulators, and the public all share the goal of zero incidents. Pipeline control rooms are a critical tool in this ongoing, industry-wide effort to continuously improve.